If you want an AI agent to read your database or trigger an action in a specific tool, you have to write custom glue code. Every new API requires a bespoke integration, meaning you spend more time maintaining connections than building actual capabilities. The Model Context Protocol, or MCP, eliminates that friction. It acts as a universal USB-C cable for AI, providing a single, standardized way to connect language models to external data. A request travels through 4 nodes: host, MCP client, MCP server, and data source. The host is the user app, the client manages the protocol, and the server executes logic to fetch data. Today, we build the MCP server, giving AI hands and eyes. This split screen shows our baseline local build. Using Python's fast MCP library, we initialize a server communicating directly over standard input and output, or STDIO. Once running, this server can expose 3 distinct primitives to the LLM: tools for taking specific actions, resources for reading static data, and prompts for reusable instructional templates. To turn a standard Python function into an AI-accessible tool, you simply add the @mcp.tool decorator above your code. The protocol instantly detects it and exposes it to the client. But here is where developers hit their first major roadblock. The LLM cannot read your source code to figure out how your tool works. It relies entirely on the function's docstring. Warning tone: if you write a vague or incomplete docstring, the agent will guess which parameters to use. This leads to unpredictable behavior, bizarre AI hallucinations, and silent execution failures. This mockup shows the MCP inspector. Before attaching an unpredictable LLM, use this browser-based sandbox to manually test tools and verify formatted JSON RPC responses. Pause the video right here. Write a simple read system info tool in your Python code. Add a highly detailed docstring explaining its exact inputs and test it in the MCP inspector until you get a clean success response. Building and testing a local STDIO server gives you a functioning desktop assistant. However, a local subprocess running on a single laptop lacks the routing, security, and logging required for a multi-user team environment. To transition this server into a remote network endpoint, we drop the STDIO setup. This code block shows how we swap the transport method to use HTTP streaming with server-sent events. Exposing a remote server directly to AI agents without strict access controls relies on vibe governance, politely trusting the AI to behave. This leaves your internal APIs wide open to misuse. To scale safely, insert a gateway between client and server. First, route all traffic here to capture logs. Second, never pass raw credentials. The gateway swaps opaque tokens for scoped JWTs. Third, require a human-in-the-loop click before firing any write action tools. Moving from local prototyping to network production means replacing blind trust with hard architectural boundaries and verifiable authentication. This macro-level map traces a production request end-to-end. A user prompt in the host interface signals the client to act. The client routes this through your enterprise gateway, validating the OAuth token. Once cleared, the request strikes the remote server, safely updating your database. This final cheat sheet maps the terrain. It covers the core primitives, tools, resources, and prompts, the shift from STDIO to HTTP transports, and scale rules requiring gateways, OAuth, and human approval. You now have the tactical code skills to build a functional MCP server locally, and the structural blueprint to deploy it securely across an entire enterprise.